Good morning, everyone. My name is Dean Allison. I'm the GIS manager at the National Lottery Heritage Fund, and I'm here to talk about how we have adopted FME, how we have used it so far, and what the benefits of using FME have been for the organisation. I've been at the Heritage Fund for just coming up to 10 months, and I've brought about 4 or 5 years of FME experience with me. And I came to an organisation that previously hadn't used FME at all, and I was very keen to start off with a solid, simple example of how we can use FME to process large data sets, automate data flows, and improve data quality. Before I start to talk about FME, I'll just take a moment to talk about who the National Lottery Heritage Fund are. The National Lottery was launched in the UK in 1994. This November we'll be turning 30 and we'll be having events up and down the country celebrating the work that we've done. In those 30 years we've awarded over £9 billion of lottery players' money to support over 52,000 projects across the UK, and that includes over £970 million of projects in Scotland, covering over 5,000 projects. As well as distributing lottery player money, we also work with a range of statutory bodies, other lottery distributors, and devolved governments and heritage organisations to allocate their funding towards heritage projects. As an example of the kind of projects we support, here are 2 examples in Edinburgh. We invested £50,000 in partnership with Nature Scotland and the Scottish Government in the Edinburgh Garden City Programme Water of Leith Catchment Project. This project gathered evidence about how incorporating flood protection and green space within developer projects within the city has both human health benefits and also benefits to developers when building properties. This supports the development of a greener city. We also invested almost £7 million in making 10 spaces within the National Gallery accessible and also improving their facilities. This is intended to reduce barriers to accessing the gallery and encourages new audience to engage with the work of pioneering Scottish artists. A final example of the projects we support here in Edinburgh is our role in the Monarch of the Glen acquisition. In 2017, we contributed £2.75 million towards the acquisition of this iconic painting by Sir Edward Landseer, the Monarch of the Glen. It brought the painting into public ownership for the first time since its completion, and the painting hung in the National Gallery for 6 months before going on a national tour of Scotland, and it's now back in the National Gallery where you can go see it yourselves today. Introducing FME to the organisation, I wanted to start with a project that was simple but impactful, and after I started I felt the best way to do this would be to standardise our grant application data sets. We have 30 years of grant application data, and over that time we've changed how it's been collected and stored. Consequently, we're left with multiple sources of grant data with inconsistent field names, and it's been saved in different formats. I wanted to unify this data into a standardized data set, and I wanted to make it spatial. FME was important here as its format agnostic design made it easy to draw different data sets together into one place. Its transformers made it easy to standardize field names and formats, and further transformers could then be used to identify gaps in the data, such as projects which have been mapped to incorrect postcodes, and it allowed me to automate a data flow from our grant application dataset through to the spatial version of the data on our GIS platform. The advantage of doing this was that we would create a unified spatial dataset of grant application that we could use in a range of self-service web apps. And we'd also improve the quality of the data we have by identifying incorrect postcodes. In addition, I also wanted to update how we map projects. At the moment, spatial data was driven by project postcode. I wanted to replace this by starting to map projects to the unique property reference number, the UPRN. Again, FME was important to this process. The tool allowed us to digest significant quantities of address data covering the United Kingdom. It allows us to identify which UPRN was most likely the address for the project so that we could join them and unify those data sets. And it also created an opportunity for me to create spatial data sets of address groups on our GIS platform. This was so that people across the organization could go onto our GIS platform and say, pull up a layer showing all the locations of museums and libraries, or art galleries, or sport facilities. Mapping to UPRN has the benefit of improving the accuracy of our location mapping, which in turn will enable us to do a more detailed spatial analysis. For example, by mapping to UPRN, we're better placed to identify which projects are in flood zones. Additionally, mapping to the UPRN brings through the UPRN classification, which helps us understand what kind of property a project has supported. Here is a map highlighting the importance of mapping to UPRN instead of postcode centroid. This is a postcode boundary covering Hyde Park Picture House in Leeds. This is a 100-year-old gas-lit cinema where we supported the renovation of the building, accessibility improvements, and the creation of a second screen. The centroid of the postcode is over here. The project itself, however, is almost 100 meters away over here. It's important that we have locations correct on maps. As mentioned, it informs our spatial analysis, but also Alwyn, the new lottery manager, want to start showing on ticket machines when you buy your lottery tickets where they have supported projects in the local area so people can better understand where their lottery money has gone. In order to do this, we need to show locations accurately on maps. Also, postcode geographies don't align with other statistical geographies. These two colours in the background here are output area classifications for England and Wales. And while most of the postcode falls within one classification, some properties fall into a different classification. In order for us to understand the communities benefiting from our projects, we really do need to be accurate in mapping out where our projects are taking place. Some background information on our grant application data. We have over 30 years worth of grant application data covering over 100,000 applicants, with the data stored in different places, in different formats, and with non-uniform field names. From our founding through to 2008, we simply had an Excel spreadsheet that contained grant application data. As the organisation grew, the need for a record management system was identified, and we adopted our first one, GEMS, in 2009. When we outgrew GEMS itself, we moved to a new system called IMS, another SQL database that ran in parallel with GEMS, with all new grant applications from 2019 onwards going into IMS, and all live projects already running being stored in GEMS. As I was already undertaking the exercise to unify our grant application data into one uniform spatial dataset, I took this as an opportunity to do some data validation at the same time. Our previous mapping had been via postcode in Power BI dashboard, and this flagged up that some projects were mapped to invalid postcodes. These were postcodes that had been either entered incorrectly or over the 30 years we've been an organisation have fallen out of use. We wanted to identify what the new postcode for the project's location was so that we could make use of the ONS postcode lookup in other self-service products. I used FME to connect to the ONS postcode GeoService REST API and get the centroids for all 900,000 terminated postcodes. I then used a point-on-area overlayer with code point polygons to find what the new postcode for that project's location is, created a lookup table and published this to our SQL database and as a spatial layer on our GIS server so that we had a way for people to replace invalid postcodes with new valid ones. Previously, this had been a manual exercise that had to be replaced every 3 months. Now it's workbenched, which is published to FME Flow, and it runs itself automatically, so there's no more manual intervention. This process identified about 6,000 postcodes which we were using, which were invalid, and replaced them with new valid data. Next, I needed to prepare my address dataset I was going to join projects to find the UPRN and exact location. First, I needed to import address base core, a 12 gigabit ordnance survey dataset containing 34 million points of data for properties across Great Britain, giving each property a unique property reference number, a single line address, and a 2-letter classification code. Next, I also needed to import Address Base Plus, another ordnance survey dataset that has a UPRN and a 4-letter classification code. These give us a greater level of understanding of what an address is. So where Address Base Core might have just told us if an address was a place of worship, Address Base Plus can let us know if it's a church or a synagogue. We also needed to import Address Base Plus Islands, which covers 1.2 million records in Northern Ireland, and all of this data was joined together into one uniform data set using feature joiners so that we were left with a unique property reference number, a single line address, and a detailed classification code from Address Base Plus for every project in the United Kingdom. Without FME, it wouldn't have been possible to complete this data merging exercise, given the sheer size of the dataset. FME lets you control which fields you import and also which records. We only needed 20% of the records in Address Base Core, so from the reader I'm able to deselect the fields I don't want to import. Similarly, we weren't looking at residential addresses as part of this exercise, so I was able to use a SQL query in the reader, and ultimately we only needed 13% of that data set. Amazingly, this brought down the size of the data we needed to import from 12 gigabit to just half a gig and 2.6 million records. The approach I took to map project grant application data to its UPRN was to create subsections of each dataset in these groups and then do a spatial join and a fuzzy match and then decide how they would be mapped. For example, I used a test filter to identify projects which fell into cinemas and theatres. So this was keywords like cinema, theatre, picture house, playhouse. I then used address-based classifications for theatres and cinemas. I took my grant application data, I joined it to the nearest 3 records spatially from the addresses group, and I would check, is the join within 1 kilometre? We didn't want projects moving too far. We didn't think it would be valid. And does the first line of the address from both records match by more than 50%? If so, we considered it a match and it was mapped to the UPRN. If not, we just left it mapped to its postcode. Here is an example of the grant application test filter I set up. And here is the test we did to identify cinema projects and some other examples as well. How we could search for keywords in projects titles, program name and description to identify places of worship, museums, libraries, and other subcategories. The same was then done with our address data using the address base plus 4-letter classifications, where I'd already used an attribute value mapper to replace the codes with a description. Again, we search through the classifications for matching words and write them out to a matching group. These datasets are then written to our GIS portal and served as a layer group that lets people, for example, just see cemeteries, crematoriums and graveyards, or just places of worship. This workbench was also my first introduction to creating custom transformers. We have a heritage area where we support places of worship, but we sometimes feel we don't have the level of detail we want when it comes to identifying specific denominations for churches. Address Base Plus does have a code that let us identify if a place of worship was a church, but here I made my own custom transformer which grouped together many test filters searching for keywords where we broke down places of worship into specific denominations. This dashboard shows the results of my attempt to map projects to the UPRN. Out of our 130,000 projects, we've been successful mapping almost 30,000, so we've got just over a 22% success rate, which we're very pleased with for our first pass, given that the first consultancy we asked about doing this work only got a 30% success rate with some trial data. We do know some of the records haven't matched because we haven't pulled in residential UPRNs for this data set. It's just too large a data set, even for FME. Also, where a project is in a rural postcode, the 1 kilometre buffer isn't sufficient, so we need to update the approach as we move forward so that we can have a different buffer for rural postcodes. Dropping the data into a dashboard has been a great way to show people the value of doing this work, as it gives us a nice indication here of how far a project has moved as a result of being mapped to a UPRN instead of a postcode. It also helps us see some of the subcategories that are now available to us. It's also created a great tool for checking what's worked and what hasn't. This will become a way for us to look at what types of projects haven't mapped and go back and create new grant application groups and also address groups. An example of something we found not quite working is when we zoom in to Leeds Town Hall. On this dashboard, its classification is coming up as a public convenience. This will be an easy fix for us. Moving forward in future iterations, we're just going to remove the classification for public convenience, and hopefully Leeds Town Hall will be mapped to a public building instead. Another example of where the visual representation of our data is helping inform how we improve iterations of this moving forward is looking at what we call the Rugby League corridor along the M62. Over on the left, we have a screenshot from our current Power BI dashboard, filtered to show projects that contain Rugby League in the project title or description. Over on this screenshot of my Power BI, of my Esri dashboard, we can see if I search for rugby facilities, I'm only getting this one project over here. Whole stretches of the M62 are rugby leagueless. We're going to take this as feedback, consider how we build it into the next run of the FME workbench, and continue to improve how we filter the data. So at the end of my first pass, I've come away with a 20% success rate. Moving forward, I'm going to be using the dashboard to share this project with people across the organisation and get their feedback on what would be other useful categories for grant applications and address data. This will give me more groupings to work with that will result in more projects mapped out. Where we continue to have a gap, I'm going to investigate using the OS address base API to pull through those missing residential records. Also, there's a potential to look at AI machine learning, as now that we have some success in this ourselves, we have more data that we could feed into the model to help us fill in those blanks. So, thank you for listening. I'm here for the rest of the day, available to answer any questions. Thank you.